Hello everyone, here is a question based on electronic configuration. Identify the coordination complexes in which the central metal ion has D4 configuration. We first need to figure out the oxidation state of the central metal ion in each case, and then we need to write down the electronic configuration. So for FeO4 2-, the oxidation state of ion will be X. Let us keep it as X, and then 4 oxygen atoms we have. Valence for each oxygen we can put it as -2, that is equal to -2 because the net charge given here is 2-. Therefore this will become X minus 8 equal to -2. Therefore X is equal to +6. So the oxidation state of ion here is +6. The neutral ion electronic configuration is argon 18 electrons, and then 4s2 20, and then 3d6. We have 26 electrons in the neutral. When it becomes Fe6 plus, then we will have 20 electrons. 6 electrons are gone, and we must remove the 4s2 electrons first because the principal quantum number here is 4. This is the outer shell. Therefore electrons must be removed from 4s first. Therefore 4s2 electrons are gone. 4 electrons from 3d6 are gone. That means now the electronic configuration is argon 18 and then 3d2. That means A shouldn't be there. A is not D4. This means option 4 is wrong. Now let us look at the next one. In B we have hexacyanomanganese complex. So X plus 6 for each cyanide ligand -1, and that is equal to -3. Therefore X minus 6 equal to -3. Therefore X will be +3. For manganese atomic number is 25. Therefore for neutral the electronic configuration is argon 4s2 and then 3d5. Now with the 3 plus oxidation state we will have only 22 electrons. Therefore now the electronic configuration is argon 4s2 electrons are gone. 1 electron from 3d5 is also gone. Therefore now we have 3d4. This means B should be there, but in option 1 we see C and E only. Therefore option 1 is wrong. Now let us look at C. We have hexacyano ion complex. So X plus 6 minus 1 is equal to -3. Therefore X equal to +3 in this case also. So this means ion is in +3 oxidation state. We have 23 electrons. Therefore this will be argon, and then 4s2 electrons are gone. 1 electron from 3d6 is gone. Therefore 3d5. So C shouldn't be there. This means option 2 is also wrong. That means option 3 is the correct choice. Let us just cross check for the other two. In option D we have a dichromium complex. Therefore 2X with acetate ligands as well as water ligands. Water ligand is neutral. For each acetate ligand we can put -1. Net charge is 0, and therefore 2x minus 4 equal to 0. Therefore 2x equal to +4. Therefore X is equal to +2. So for chromium the atomic number is 24, and for the neutral the electronic configuration is argon 4s1 3d5. Because chromium it is half filled. Half filled will be more stable, and therefore we have to write it this way. Now it is chromium 2 plus. For chromium 2 plus we will have only 22 electrons. Therefore now the electronic configuration is argon 4s1 electrons are gone. 1 electron from 3d5 is gone. Therefore this is 3d4. So D is 3d4. How about E? For E, hexafluoronickel complex. So X plus 6 minus 1 equal to -2. Therefore X minus 6 equal to -2. Therefore X will be +4. Atomic number of nickel is 28. Therefore, for neutral, the electronic configuration is argon and then 4s2. That makes it 20 and then 3d 8. Now for nickel 4 plus, we will have 24 electrons. Therefore, now the electronic configuration is argon and then 3d 6. Therefore, E also shouldn't be there. This means that option 3 is the correct choice here.